Na, 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 na. Yo, what's up, everyone? Welcome back for our final stretch run of the year, April 12th, and it's already week 3 of our fourth quarter. I mean, I feel like the third quarter went by insanely quick. Like, what I was thinking about over break was like, it's crazy how this year is pretty much almost over. And in this class, we only have 2 units left. Okay, so we're only learning 2 more things. And the first of those 2 things is logarithms, which we're going to tackle for the first 3 weeks. Hopefully, I think 3, 4, and 5 weeks, 3, 4, and 5. And then we're going to do trigonometry for the end of the year. So, you know, I kind of love algebra 2 because you really learn quite a bit of math. So if you've been with me the whole time, I think you have a lot to be proud of. Like a lot of different topics you've learned. We've covered like so much different math, and that's what algebra 2 is all about. So just 2 more things: logarithms or logs, and a trig. And it's just going to be videos the rest of the year. Um, some people are going back, and I think that that's kind of really complicated. And I'm not going to go back. And the primary reason is like, none of you guys are going to be vaccinated. I'm fortunately vaccinated, which is really good. But it's not a safe situation for students, so I'm not going to kind of be a part of it. That's my thinking. So this class is going to be the exact same for the fourth quarter. And I am anticipating some things kind of being a little crazy with the going to school stuff. So the school might be wonky for this fourth quarter, but this class is going to be the exact same. We're going to finish up the same way that we started, which is these video lessons. So I put in a few reference questions, which just meant questions that I answered myself. And those are questions related to exponents, right? So our last unit was the exponent unit, and this is the log unit. And we talked about logs just in that last video lesson. And the big idea is that a log expression is just a rewriting of an exponential, okay? They are talking about the same thing or the same concept, okay? They just flip around the numbers. So I showed you just this 9 cubed, something we've seen all the time. 9 cubed equals 729 is an entire kind of expression, right? Any math equals something, right? So you have to be aware that 9 cubed, this is a 3-number relationship. And I'm saying that really poorly, right? You have the base number, you have the exponent, and then you have what it equals, right? When you take this number and multiply it to itself this many times, it gives you the other number. When you have a log, all it does is it flips this top number and the what it was equal to, or the right number. Okay, it's just going to flip them. So if you were to take this expression, 9 cubed equals 729, and write it in logarithmic form, you do that by flipping the 3 and the 729 and putting log in the front. Okay, so log 9 729 equals 3. Okay, and I know this is really kind of funky, but these are equivalent expressions, right? Log base 9 of 729 means this number multiplied to itself how many times will give me this, and that's what this equals. Okay, so if you see a number to an exponent, that's pretty easy. Multiply to itself that many times. But if you just see a log expression, this is where you have to start getting used to understanding what it means. And this means what or how many times do we multiply this to itself to give us this? Okay, so again, that's a big idea, and let's kind of expand that. If we see this and it says convert the log into exponential, an exponential equation, then solve, we have log base 7 of 16,807. Now this is important for a few reasons. The first is this is not one that you like have in your head. right? In the exponent unit, there's like a lot of numbers that are, common. Even 729 is fairly common. This is a number that's not common. We're trying to figure out 7 multiplied to itself how many times gives me this number. And that's what this is going to equal, okay? So it's a really big number, and then the answer becomes a small number, right? The small number is always the exponent itself. And in this case, the exponent goes to the other side. So if you're ever trying to figure something like this out, a really easy strategy is multiply your number to itself, right? We know it's 7 multiplied to itself how many times gives us this top number. So it's not 7 times 7. We know that's 49. You can keep going and essentially count your 7s until you get there, right? So think that 7 times 7 times 7 times 7 times 7, 1, 2, 3, 4, 5. Yep. 5 7s gives me this number. So the answer is 5. Okay. So hopefully that makes sense. Hopefully that's not too complicated. But if ever says to convert it into an exponential equation, think that this is just what we were saying out loud. 7 multiplied to itself how many times gives me 16,807, right? So hopefully this makes sense. This is exactly what we were doing before. It's not anything new quite yet, but hopefully you get more and more familiar with a log. And like the way that I really like to think about it is it's the opposite of an exponent. Base number, the big number equals the small number, not base number to the exponent equals the big number. What can be more complicated is when your logs get more tricky, right? So if you're not like an expert with your your exponential rules, it's gonna come and bite you for this unit as well. What I mean by this is we see log 81 of 3. And what this means is 81 to what power gives me 3. So I'm just gonna write that in to start us off. And what's hard about this is that if we raise this to the second power, to the third power, etc., this number becomes bigger, not smaller. So in this case, we can't forget that we can use fractional exponents to indicate square roots or radical signs, right? We go the opposite, right? 3 to the 4th gives me 81, and this is kind of an example we've talked about a few times, so that's why I'm speeding through it. But 81 to the 1/4 power gives me 3, right? So the answer to this is 1/4. And again, like actually for this one, maybe we should be clear, because 7 to the 5th equals this, and that's how that works. Here, 81 to the 1/4. So the logs where you're using the weirder exponents, they could be tricky, but we talked about that last lesson. Okay, so that's a quick overview. And now we're going to get into kind of the new stuff. And that's simplifying one of these log expressions. Okay, so the big idea is we're trying to simplify some of these logs, 7, 8, and 10. And by simplify, I mean we want to rewrite it as a single log. So what we see is log base 6 of 36 plus log base 6 of 7776. And we're going to reference this exponential one because what I want you to remember is we're already used to simplifying exponentials, right? So for number 5, we see 6 squared times 6 to the 5. And what we know is that, you could do this by solving them separately, right? 6 squared is 36. You can multiply that to whatever 6 to the 5th is. So simplifying it isn't going to make it necessarily even easier to solve, but it's just kind of important to understand the rules. And the way an exponent works is 6 squared means there's 2 6s. 6 to the 5 means there's 5 6s. So think that there are 7 6s total, right? So we can just add their exponents up if the same bases are being multiplied together. This is going to go pretty much the opposite, okay? So first, this is actually kind of easy to solve. If we see log base 6 of 36, what that means is how many times do we multiply this to itself to give us this top number? And that's 2, right? In this case, it's not too difficult. 6 times 6 gives us 36. For the second log, it's not as easy to do in your head, but I keep forgetting. I forget if I even posted it, but there's this thing called the power table. That if you ever want to try to find harder powers, this is every power that we've kind of talked about. So I use it. I linked it, I think. I'll try to link it again. But the other way to do it is like if you want to figure out 6 to itself, how many times it gives us this, just multiply like this. So it's not 4 times, but 5 times, right? So 6 5 times gives us 7,776. So that would be the answer to this log, right? So we can actually already solve this as 7. So in this case, it's actually easy to solve. This log plus this log individually gives me 7. But we want to figure out, can we rewrite this or put these two numbers together, right? So what we're going to do, and the rule here, is that we can multiply the top numbers together to give us this log, okay? And this is something that I kind of find a little tricky to explain. But the first thing to notice is they have the same base number, right? So they both have base 6, and both of these are numbers that you can raise 6 to the power 2. All this side is 7, right? So let's think that 6 to the 7th power gives us what number, right? So we can even put that on a calculator. 6 to the 7, really big number. Let me just write it down. But actually not even that big. That's the number, and we already saw it in this one because these kind of go together. But if I wanted to combine my two logs, all would have to do is multiply their top numbers together. Okay, so these two logs are equivalent to this, because log base 6, 36 times 7776. If you multiply those two numbers together, you get this. And I think, maybe you're kind of seeing the whole picture. Hopefully you're kind of seeing the whole picture. This is 2 6s. This is 5 6s. So there's 7 6s here, which is what this equals, right? So if you ever wanted to simplify, and make this a single expression, let's say you don't care about solving, but you just want to simplify it, all you have to do to combine them is you multiply those top numbers together. So it works the exact opposite of an exponent. And an exponent, the same bases are being multiplied together, and then you add up their top numbers. Here, we have same base logs being added together, so we can multiply their top numbers, and that would be how we simplify. I hope that makes sense. Maybe I should have had another example here. The same rule we can apply to subtraction, and it's going to be almost like obvious. If you see subtraction, you could solve them separately. That's allowed. But we want to find a quicker way to do this, right? Instead of doing them separately, we want to find out, how can we solve this with a single log? And if you see subtraction, it's going to be division of your top numbers. So, just like so much this year, addition goes with multiplication, subtraction goes with division, but we can simplify it by taking those top numbers and dividing. In this case, we get 5 And we're getting a pretty weird log here, which is log base 5 of 5. And the answer to that is just 1, because 5 to the first power gives me 5. So you could have done this separately, because we know that 5 very quickly to the 4th power, I'm pretty sure. Crap. 5 to the 4th. Nope. 5 to the 5th gives me that. And 5 to the 4 gives me that. So 5 minus 4 equals 1. But if you wanted to simplify it, you could take the top numbers and divide and turn it into the single log expression. Okay, so I think this is fascinating. Hopefully you also think it's amazing and this is hilarious, but I'm gonna skip the challenge and we're gonna talk about that next time. Let me just write one more question. This would be number 9 for us. And just so we understand the rule, if we wanted to simplify this, as in turn this into a single expression, the same way we could turn this into the single expression 6 to the 7, all you have to do is take the top numbers and multiply them together. And in your head, you can already kind of visualize. This is 3 threes, this is 4 threes, it's going to be 7 threes. So 27 times 81, which is the same thing as 3 to the 7. Alrighty, hopefully that wasn't too bad. Again, I think this set of lessons is tricky, and we're building towards graphing it, which will make it make all more sense. But right now, our big kind of thing is simplify the logs. That's what today's all about, and we'll do a bit more next time. Alrighty, proud of you and appreciate you.